Hi, everyone, and thank you for attending today's webinar, Maximize Your Data Center Efficiency with StarWind Hyper-Converged Appliance powered by Mellanox 100 Gigabit Ethernet Network. And at the end of the presentation, we will have a Q&A session and cover any unanswered questions. At this time, I would like to introduce our presenters. Joining us today is Moti Beck, Director, Enterprise Market Development with Mellanox Technologies. And also Max Kolomeitsev, Product Manager for StarWind. At this time, I would like to turn it over to our first presenter, Moti.
Thank you, Brianna. Hello, everybody, and thanks for joining our webinar. And just before starting the webinar itself, let's spend some time about telling you about Mellanox to those that don't know us very well. Just in brief, Mellanox is a company that provides end-to-end solutions for data center. And we have all the technologies and all the speeds, all the standards that are in the data center itself, including the Ethernet, RoCE, which is RDMA over converged Ethernet, and also the InfiniBand. We support all the speeds between 10 to 100. That includes 25, 40, 50, 56, that is particular for InfiniBand, and of course the 100 itself. Mellanox is unique. We are not just providing the end-to-end solution. We are doing all the products ourselves. All the components that are part of our solutions are done by us, designed and manufactured by us. This includes the IC, the controllers themselves, the NICs, the adapter card, the switches, software that helps you to manage and control the data center, and also the cables itself that are pretty challenging those days because of the 100 gig per second. So the question that you can ask yourself is why suddenly, while most of the deployments today is over 10 gig, why we decided to go to higher than 10 gig up to 100? And the reason that basically, as it is for today, based on the market trends, the 100 pretty much maxed out. In the data centers, they started to be ultra fast and ultra scalable. The demand for higher bandwidth and lower ROI or higher ROI is growing. And for doing it, you need to support more virtual machine per systems. You want to maximize your CPU utilization. You don't want, when I'm saying maximize CPU utilization, you don't want to spend too many cycles for running jobs that are not associated with the application itself. And of course, you want to use less space to maximize the space that you have and less power. So those are the market trends. We are also living in the mobile world that you need to support hundreds or millions of mobile users in every day. And processing of data in real time is pretty much given those days. So it's not just doing it, but also doing it on time and the most efficient way. So this is one of the reasons, and that's why the 10 gig maxed out, and the industry actually requested and already deployed higher than 10 gig, whether it's 25 or actually those days the 100. Our products includes more than the 10 gig, include the recent products that we introduced that includes 4 components. One of them on the bottom, the Link X, that includes our cabling products. Those are the copper can support up to 6 meters, 100 gig per second, and it's pretty challenging to support 100 gig per second on copper, and we have it not just on copper, but also on optical, 2 products, VCSEL and silicon photonics. The NIC is our Connect X4. The Connect X4 can support all the speeds between 10 to 100. If you don't need the 100, you can use our Connect X4 LX that can support up to 50. That way, 1025 are using SFP plus connector, and 4050, and if you want 56, that also Ethernet, it's not an industry standard, but we support it, runs over QSFP. The connecting all of them is the Spectrum. This is our latest switch that can support up to 100 gig per second, 32 ports. If you don't need the 100, you can use each one of the ports in a lower speed, and then with the splitter cables, you can support more ports. Our Spectrum is the leading product, the switching product in the market today. It's open. This is one of the things that Mellanox is very proud about. Since day one of the company, we supported the open technology. Even the InfiniBand that the company started with was open industry. And we give our customers the opportunity to use the switch with other networking systems, whether it's Cumulus, that we announced a couple of weeks ago, their own operating system, networking operating system, or if you want to do, you can use our own, the Mellanox operating system with a very stable and rich SDK that you can port your operating system to run over it. The other product that we have, you can use industry product that helps you to manage and control the data center, but you can also use our own Neo. So as you can see, we have the full end-to-end solution. Everything is developed by Mellanox. So actually, you can ask yourself, basically, how we came to the 100 gig per second. And on the left side, you can see like what happened about more than 40 years ago when a guy called Bob Metcalf developed or started to promote the idea of Ethernet. And at the time, it was very low speed. And let's say, I don't want to cover the all 40 years, but about 40, or I would say 30 years later, at the beginning of 2000, specifically 2003, the industry had the 10 gig. And within the 10 gig, the roadmap was that the 10 gigs were going to be over one LAN. If you need to have more than 10 gigs, then you are going to use 4 LAN to get the 40 gig. And according to the IEEE industry, the next speed was 100, that was 4 by 25. So this was the roadmap, the original roadmap that the IEEE has. Once we started to see that there is higher demand for more than even 40, and Mellanox actually is providing the leader on the 40 gig today, we believe that we have more than even a 90% market share. The industry requested not just the 100, but something in between. We asked the IEEE to standardize the 50, which is 2 by 25, and the 1 by 25. This is the 25 and 50. The IEEE at the beginning didn't accept it, and then with leading companies like Google and Microsoft, we promoted the industry standard that eventually was adopted by the IEEE. So today, those are the standards, and you have the 25, 50, and the 100, and the 25 is going to be the next generation, or the next 10, 50 is going to be the next 40, and the 100 is here as well. So it's going to be pretty simple migration path. There is no need to do any modification to the current architecture. It's the same connectors. The 25 is the same connector as the 10. This is a SFP+. The 50, the same connector as the 40, USFP. But you are going to get a better cost. You can see here on the left side how the deployment is being done today on the 1040 between the storage and the compute, and on the aggregation layer. You are going to get the same but much higher efficiency when you are going to use the 25, 50, and the 100. Pretty simple, very easy migration, just higher efficiency. Just to show the efficiency, this is a POC that we did a while back to show the effect of higher bandwidth or networking bandwidth on the efficiency itself. And performance actually affects the ROI. In this particular case, it's a VDI deployment analyzing if you need to have 5,000 virtual desktops. As then you can see on the table, the number of desktop per server is going higher with the higher the bandwidth is. So the number of desktop, you have more virtual desktop per server, you need less servers, you need less switches, you need less cables. So you can see actually here the effect, it's between the 10 and 50 is about 3x better efficiency on the 50. And we didn't do yet on the 100, but it's going to be much higher. So this is one way or one benchmark that shows the efficiency. Another development in the industry is about the recent development, not so recent, but the recent development on the storage itself, that the hard disk drives start to be history, and you start to see more and more flash or SSDs, specifically the recent ones that are the NVMe flash drive. And with one Connect X4, you can support up to 3 of them. Of course, you can use less than that, but then you need to have more NICs, more cables, more switch ports, which is going to affect, of course, the overall space, power, and it's going to cost more. This is showing the strengths, and this is where the 100 shines, and this is we'll discuss later, showing how the 100 is being used on a storage appliance or hyper-converged appliance. Another way to increase the efficiency is not just to use the Ethernet, but to use the Rocky. On the right side, you can see POCs that we did about a year ago, showing 100 gig running over TCP/IP on the left side and Rocky on the right side, which means that it runs over RDMA. Just in brief to the guys that don't know what RDMA is, basically RDMA totally offloads the transport task from running on the CPU to the I/O controller itself. When you are running TCP, you need to run the TCP stack. Pretty heavy stack, needs quite a lot of cores to run. And today the CPUs are pretty expensive, about at least the recent one with 12 cores are about $2,000 each. And you don't want to use the CPU to run jobs or tasks that are not associated with the workload itself. So you want to offload it to the I/O controller that is pretty much 10% of the overall cost. The cost is 10% of the CPU cost. So on the left side, you see that about 8 cores were used to run the 100 TCP/IP, and this is why actually we got only 54 gig per second. Of course, we could, if we wouldn't limit, we would be able to get 91 like we got on the Rocky, but then not much would be left to run the application itself. So it's not just the technologies that we have, it's not just about higher speed, but also efficient offloads that makes the overall solution much better. And there are other technologies specifically for the storage, like ICER, that will go deep a little bit later. ICER is iSCSI over RDMA that makes the access to the storage itself faster. So in summary, again, if you are deploying now a new or considering to deploy now a new infrastructure and to build your next generation data center, it's going to be beneficial for you to consider higher bandwidth, using higher bandwidth, the up to 100 gig per second. And to do it, actually, we are supporting your needs, and we have mechanisms that allow you to submit a request for a POC. If you will write us an email to winapoc@mellanox.com, WINAPOC@mellanox.com, write the name and send us the information, and we'll send you the gear, we'll consider it, and we'll send you the gear up to 90 days. So this is one way that you can check and analyze the efficiencies that higher bandwidths will provide. This basically concludes my presentation, my portion. Of course, I'll continue to answer questions, but with this one, I'll move it to Max from StarWind that will describe the appliance, the hyper-converged appliance that they moved from the previous generation bandwidth to the 100. Max?
Okay, Moti, thank you for an excellent presentation. Glad to be here. And yeah, definitely it's a really interesting transition we recently made with our highest line of the appliances. As more and more data appears in our customers' data centers, there is need to analyze it and make use of it. I won't even mention Moore's Law anymore. It's not only about CPU cycles. Right now, the more sense we can make of the data, the better it is for the business. So the key is to start asking your supercomputers the right question. And StarWind idea is to bring supercomputers to your data center without actually buying giant racks, but just having them in small form factors, like let's say 4 units or 8 units will totally suffice for some homegrown nuclear analytics. Now, a little bit about StarWind's hyper-converged appliance. It employs all the components one needs to fulfill his application demands. In this particular case, these are almost the top-notch, the most I/O demanding applications. Thus is our decision to switch from 40 and 10 gigabit Ethernet to 100 gigabit Ethernet with the help of Mellanox technology. StarWind's hyper-converged appliance delivers amazingly fast and easy way to manage your business-critical applications. It unifies commodity servers, storage, networking, and the hypervisor into a single manageable layer. As you can see on the picture, there are multiple brands involved in this appliance. We try to utilize only the best-of-breed components. Here is Dell servers, Mellanox networking, Intel flash technologies, best-of-breed hypervisors of choice. It can be either vSphere or Hyper-V, and we're working on supporting other hypervisors as well. Now, StarWind does the storage management, and in order to fulfill the backup plan, we've got Veeam working for us, and we can also do disaster recovery to Azure. Now, just some coincidences. I didn't want to overload the presentations with graphs showing history, that this were the dinosaurs, this was the pre-virtualization era and stuff. So I'll just mention some interesting coincidences from the industry. Doesn't mean StarWind is the one who pushed the whole industry going to flash and 10 gig or 100 gig, but we definitely have our trace in adopting that high tech and increasing the actual adoption by small and medium companies. Now, back in 2011, we saw that along with SSD spread and virtualization, 10 gigabit Ethernet became a commodity in most of our environments. That seems obvious, but it's an interesting space where we first showed that StarWind and iSCSI can operate at high I/O rates when we showed the initial test result where StarWind tested performance and showed 1 million IOPS. This was a small step pushing people towards 10 gigabit Ethernet and seeing it as a good alternative to existing fiber channel configurations. Now, as we later saw PCIe SSD adoption, like let's say Fusion I/O, more and more cases, people just considered Mellanox 40 gigabit Ethernet. And from our internal statistics, we see that up to 80% of setups utilized 40 gig E. The remainder used teamed 10 gigabit Ethernet, or they considered 40 gigabit Ethernet. Now, after 2013, we really see the history of NVMe SSD adoption. So first we saw it adopted by few universities, then there were 2 or 3 cloud service providers trying to increase the performance of their highest tier. And these companies were already using 40 gigabit Ethernet. That was the default uplink. There was just 2 1 gigabit ports for management. Everything else was packed with 40 gig Ethernet. And they were exploring faster options. That was the first time when we explored how we can go higher than 40 without just using 50 or 56 gigabit. That is when we did our first experiments with 100 gigabit Ethernet with Mellanox. Nowadays, in the nearest future, we will see the release of 3D Crosspoint. If you're not familiar with the technology, it's basically NVMe, but it's 10 times more dense, it's much more durable, and it will be much more affordable. So basically, the whole market will explode. Imagine that you have an option to go all flash for half the price you typically see when looking at all flash solutions. So as soon as the new technology appears, the demand for higher performance networking interconnect will explode as well. So this will be 2 next big events in the interconnect and storage performance world. And I have some question marks here to kind of check if that prediction is right. I'm 99% sure that we will see that, but maybe Mellanox will release 200 gig Ethernet, and that will be more adopted than 100 gig. Who knows? Now, question we are getting from our customers, why 100 gigabit Ethernet? What was so wrong with 40 gigabit? Well, nothing wrong with 40 gigabit. There are just some applications and workloads which benefit from 100 gigabit Ethernet. So that's absolutely not a question to a particular model. It's just the case where you need as much as you can get. And as Moti said earlier, ROTI is a crucial part of high-performance networking. Essentially, if 10 gig E was an instant message to your smartphone, 100 gigabit Ethernet and ROTI is just equal to telepathic messaging right into your brain. And a new acronym Moti mentioned previously is ICER, which is essentially same brain-to-brain interface, but for the storage. And as StarWind leverages servers RAM as distributed wide-back cache, for us it is really important to use all the optimization technologies to synchronize that RAM between the boxes as fast as possible. Mellanox 100 gigabit Ethernet makes this a reality. Now, also 100 gigabit delivers huge flexibility to the cluster networking. Virtualized networking will never become a bottleneck if you have 100 gigabit pipe between the servers. It is really easy to manage. You can always provision more performance to your system. You're not worrying about your interconnect being a bottleneck in any case. And of course, future-proof design. As I mentioned on the previous slide, we have new technologies of just popping up, being first available as test product engineering samples, but just in a few months we'll start seeing those technologies appearing in all solutions. And I'm talking 3D Crosspoint, Intel Optane, NVDIMMs from various providers, giving you an ability to utilize, not only utilize that 100 gigabit Ethernet. Our idea is to get maximum performance for the applications. And these are the best instruments to make sure we get high performance from the storage stack and we get high performance from our networking stack. I only hope the next bottleneck will not become a CPU and it will develop in a balanced manner without bottlenecks. Now, a quick comparison between our standard hyper-converged appliance, the all-flash appliance, and the NVMe-based appliance we're discussing today. As you can see, there is a 50 times difference between the NVMe and standard hybrid SAS plus SSD configuration. So we're talking about really I/O demanding applications. Some people who want higher performance jump from hybrid to all-flash configurations, but for ultimate performance and for really high I/O applications, the NVMe option is the best answer. As Moti told previously, 3 NVMe drives can easily fill the 100 gigabit interconnect. We employ that in redundant manner, so we have multiple links between the servers, allowing us to raise the performance bar up to 1.5 million IOPS environment. And of course, the only thing you need is an application which can push that limit and actually use it. Now, a question a lot of people are getting, how do I employ this new technology in my existing environment if I have a 1 gigabit or 10 gigabit or 40 gigabit Ethernet? So this is something Moti partially answered previously, saying that there is similar interconnect between 2550 and 100 gigabit in their product. And StarWind complements that fitting into existing networking stack by providing an alternative solution. Even if you don't have a 40 gigabit network in place or 100 gigabit network in place, if you want to start your experience with 100 gig E clusters, StarWind provides a minimum starter kit with just 2 servers. And in this case, it is possible to interconnect the servers with a direct cable, bypassing the switch. So you can start using the technology without actually upgrading your entire infrastructure. You can still use the 10 gigabit uplinks to connect the cluster to your clients, or it can be 40, it can be 50. And in the backend, StarWind will unleash the whole performance of 100 gig E on the application level. Now, we discussed some specifics about StarWind hyper-converged appliance featuring NVMe and 100 gig E, but let me take it a step or two back and actually talk about the benefits StarWind hyper-converged appliance brings to the data center. First one is it's hyper-converged, and while this may be a hype word, or this may be something industry is pushing hard right now, but for a fast environment like in our case, so we're talking NVMe storage, being hyper-converged is the only option to deliver consistently high performance, because the traditional environments which utilize dedicated storage often become bottlenecked by the interconnect between storage and compute layers. In case of hyperconvergence, StarWind talks directly to the local storage, in our case RAM, DRAM, in future it will be NVDIMM, and of course NVMe. So having anything sitting between these storage resources, the application dramatically drops the performance and increases the latency. We want to omit that, so we put our storage as close to our application as we can. Then, a really neat feature of StarWind is the flexibility of protocols we can use. Now, even though we do iSCSI and iSER planned for release shortly, we can also support sharing out storage using multiple protocols, including SMB3 with SMB Direct and NFS, and we also support all the additional features like vVolt on iSCSI. And we're planning to release an alternative for Microsoft World for that. And we're also working on some NVMe over Fabrics technologies to make sure we're one step ahead of the data center infrastructure deployment. And a small thing which I may have mentioned earlier, StarWind leverages local RAM as cache. This is the fastest possible resource we can get. So we just try to make use of it and use it as our write-back cache. And RAM is volatile, so we synchronize that cache between the participating servers for maximum reliability. Now, a few more features about the appliance. By default, StarWind is delivering highly available data. So the whole history of the company stands on availability and uptime cornerstones. StarWind has always been known for delivering highly available storage, and this is something we keep in the hyper-converged appliance ABS. So we mirror the NVMe storage between the servers, we mirror the RAM between the servers, and if there are additional storage resources, we will keep a redundant copy of that on the cluster nodes to make sure that if a node fails, the application seamlessly and painlessly restarts on the other node or continues to work on the other node if you employ fault tolerance. And of course, the solution also features asynchronous replication, which is effectively DR solution for individual virtual machines or applications, or it can be volume level replication to a public cloud or any DR location. That's your call. These options are configured in parallel, so you can have either one or you can have both at the same time. That is your call. Now, the hyper-converged appliance supports multiple hypervisors, and while with vSphere, there is a big unified management console being the vCenter. In some cases, the only alternative Microsoft can offer is the System Center Virtual Machine Management, which is a good product. It's a great set of tools. However, it has an increased hardware footprint and some complexity which is not necessary in smaller environments, even though they are tailored for ultra-high performance. So for smaller environments, we use 5.9 Hyper-V Manager with StarWind and Veeam integration to make sure we can manage all the components of our appliance from one place. It provides a really neat way to manage our virtual machines, our clusters, our storage, and our backup from a single window. It can be a centralized console, or it can be launched on the appliance itself, delivering better user experience and easier management. And critical part of it is the storage monitoring, especially when we talk about NVMe, because if something goes wrong, we need to replace the storage really fast and make sure that our applications do not suffer the underlying hardware problems. Flash is still not so long-lasting as drives, and there are no RAID 10s for NVMe. For now, it's too expensive, so we use smaller number of drives. So monitoring and being on par with your infrastructure is critical. We want to make sure that the administrators using StarWind appliance have that option. Now, Veeam integration is a really easy way to monitor your backup jobs, see if anything has failed, if the job's finished correctly, and also manage the whole backup process from the same window where you manage your virtual machines or your applications and your storage. And one more thing which differentiates StarWind from lots of other options, including the so-called do-it-yourself scenario and other hyper-converged options. We do provide a single support umbrella for all applications and hardware we provide. So should there be any issue, even if it's Hyper-V or vSphere or StarWind or Veeam or any other part of the appliance, you contact StarWind and we solve this problem for you. This provides both unified single point of contact, or like people tend to say when it comes to support, a single throat to choke. And it also removes the finger pointing issue, because oftentimes in a multi-vendor environment, when we contact, let's say, hypervisor support, they say, no, it's not our fault, it's storage provider. Then you contact the storage provider, and storage provider points that this is actually a hypervisor issue. And you can be in that hell circle for hours and hours or even days, and that's not something you need when you have lots of money and maybe your whole business at stake. So it's something we try to remove off our customers' shoulders and utilize our contacts in the vendor companies to get better support and make sure that customer experience is excellent even when there are multi-vendor issues. Now, I wanted to talk about the applications for such an appliance, because people may think, wow, 1.5 million IOs, where may I need that? Why do I need it at all? We're talking spaceships, but we don't have highways in our country. And the applications may be really surprising, and a lot of companies are starting to look into implementing such clusters in their company. Well, previously they went to universities who had supercomputers to run some analysis and make sense of the data they got. Now they can do it in their data centers. So essentially this is called big data, when you not only gather the data, but you also make sense of it and do some good things to your business using those statistics. Like, let's say you could look through the weather forecast and see if the hurricane is going to interrupt any of your businesses. And on that, make a decision if you need to migrate that business, if you need to evacuate people, if you need to put some appointments with the power company to make sure they come in and fix the electricity in a timely fashion. Now, cloud computing applications, this one is more obvious. A lot of people are moving their whole production to clouds. On the other side of the cloud, people need to make sure they deliver highest possible performance for all their customers. And one of the few ways to do it is to employ NVMe storage and to make sure that that infrastructure NVMe supporting is reliable. We need to synchronize it. So here comes StarWind's hyper-converged appliance, allowing you to deliver super high performance and maintain reliability for your customers. There is lots of use in such appliances, in the digital content market, where you need to stream data, you need to quickly process huge amounts of it. Typical tiered solutions really don't work because of the latency and multi-tenant access issues. Kind of a partial case of big data is scientific research, when people run modeling on computers instead of using real tests. So most of the car vendors use mathematical models in most of their vehicle security and safety tests. So the ones you see on YouTube with a mannequin hitting a concrete block is just few percent of huge array of tests which are performed on computers. And systems like StarWind HCA can be the foundation for such test environments and actually deliver results which can save millions of lives based on the mathematics running on the systems. And more interesting and controversial is the economic analysis. The trade can be analyzed, the economic outcomes of currency exchange rates and commodities exchange can be modeled on systems like that really fast and deliver answers to companies whose business is based on trading commodities. Do I need to sell it today? Let me check it with the supercomputer. Supercomputer will tell you the possible outcomes. So the possibilities are endless. As I said, the biggest challenge so far is to start asking our supercomputers the right questions because they are already here. That was my part of the presentation. Thanks to everyone. And we now come to the Q&A session, and I will gladly answer all the questions you may have. And Moti will join me on the Q&A session.
Okay, so it looks like we've got a couple questions here. One of the first ones is, which operation systems and hypervisors support already 100 gigabit Ethernet?
So I'll answer it because this is the Ethernet driver questions. So I would say that today you can find, of course, the support of the 100 Ethernet on the Linux, whether it's the operating system itself or the hypervisor, the KVM. Another one that is coming, and it's pretty open common knowledge or public, is the Windows Server 2016. Actually, last year, this is what we used to run the benchmark that shows the difference between TCP/IP over 100 and Rocky. So those are public, and the Linux and the Windows, and probably very soon you'll see other that are coming, although it's not public. So roughly speaking, all the, I would say, operating system in the data center, or the common one, is already inbox or about to announce it pretty soon.
Looks like we also have another question. What workloads can benefit from the 100 gigabit Ethernet?
So I know that Max already answered those, in the last slide, but I want to elaborate a little bit. So if you take a look on the overall workloads that runs on data centers, I think that the one that can benefit very much from the higher bandwidth is actually the database. Database is all about running or transferring data from one node to the other, assuming that you're running the database in a scalable and distributed environment. So this is one environment that you can, of course, benefit from this one. Another environment is for storage. Those are the systems that, if you need to run a backup or a disaster recovery, faster you are doing it, better it is. So definitely this is another area. And the third one is in any virtualized environment. At the end of the day, if you need the VM and you need, each VM needs to have its own set the storage or the memory, it's better that you'll be able to support more VM per server. Otherwise, you need 2 servers to do it. So this is where you can leverage higher bandwidth. I would also add another about the Rocky itself, and this is when you are running Rocky 100. This is where you are running applications that are sensitive, I would say, to the latency. And if you need to do it in real time or to get the results in real time or in almost real time, this is areas that can benefit from higher bandwidths and lower latency networking. So I think that we got a couple of other.
What is mirroring and storage on the servers? Are you using an additional VSA to manage the data?
So StarWind Virtual SAN is the storage engine behind the servers. And the answer to VSA question is both yes and no. So in Hyper-V environments, we do not use any VSAs. We just use native StarWind application running in the parent partition. And in vSphere environments, StarWind works from inside the virtual machine, so it technically can be considered a VSA. And to add to that, I would say that we also support additional data movers because recent statistics show that there is no one good way to manage the entire hyper-converged infrastructure. So it is completely possible to mix StarWind with existing SAN or object-based storage, like let's say VMware vSAN. Two solutions can well play together sitting on the same hardware.
And we just got another question. Do you have benchmarks comparing 40 Gigabit Ethernet and 100 Gigabit Ethernet performance?
I do not have. Oh, okay, Moti, your turn, I guess, higher level networking, and I can add about storage later.
Yeah. So on the low level, definitely we have. On the low level, we, for example, the one that we did, I showed in the presentation, it was on the application level, we don't have yet. We are working on it, but as you could see on the VDI, when we did the application level, the difference between 10 to, I believe it was 50, it was about 3x. I would expect the same. I wouldn't say that it's linear, but I would say that we can expect about, roughly speaking, 6x higher efficiency when you're using the 10 gig, the 100 compared to the 10. So this is why we actually said that, we believe that the 10 gig maxed out, you need more VM, you need higher bandwidth, and of course the higher efficiency. But we will publish the low-level benchmarks soon.
We also received a question, does this appliance work with non-virtualized applications?
Is it Max, you'll take it on?
Yeah, definitely. Yes, StarWind does work with non-virtualized applications. If you have, let's say, databases like that you don't need to virtualize, and this will be the only use of the appliance, you can definitely install it right next to the operating system, and this will work. Absolutely.
Okay. I believe that's about all the time we have for today. And if you have any questions, you can always contact us at info@mellanox.com. And thank you so much for attending. We hope you enjoyed it.
Bye-bye.